Okay, so welcome to my third video in which we are discussing the Synaptotagmin function, where we're specifically looking at how Synaptotagmin binds to Syntaxin 1. Okay, so I just described to you this experiment where we can assay whether Synaptotagmin binds to Syntaxin 1. Well, basically I missed out one little key addition to this. That in order for this to happen, in order for you to get Synaptotagmin found in the pellet indicating that Synaptotagmin is binding to Syntaxin 1, you need to add calcium. Okay, so this only happens basically when Synaptotagmin has bound calcium. It only binds to Syntaxin 1 if you have put calcium in its presence, basically. So calcium binds to these C2a and C2b domains, and then it will bind to Syntaxin 1. I also just want to discuss what actually happens to the C2a and C2b domains when calcium binds. Does the conformation change? Well, no is the answer. And this is the really ingenious part, because neurotransmission needs to be extremely rapid. You need the calcium signal to come, and you need Synaptotagmin to be activated very, very quickly. Conformational changes are time-consuming, potentially. So these two domains, C2a and C2b, when they bind calcium, C2a 3 calciums bind, and C2b 2 calciums bind, they do not undergo a conformational change. Instead, what happens is the electrical potential of the C2a and the C2b domains changes. So the electrical potential rises when you increase the amount of positive charge on there. Each one of these calcium ions is a divalent cation, so you're adding effectively 6 positive charges onto C2a and 4 positive charges onto C2b. So adding positive charge somewhere increases the electrical potential. So what the change that these calcium ions bring about is in the electrical potential of the C2a and C2b domains, and then these domains combine to the Syntaxin 1. Okay, and we'll continue our discussion of the function of Synaptotagmin, turning our attention to it binding to the lipids in the next video.